In this last example 6, we are actually going to be graphing a piecewise function. Example 5, we were substituting values of x into the function. We were evaluating the piecewise function for values of x, but now we're going to be graphing it. And it's pretty much the same as example 5. It's a piecewise function. It's 3 different equations kind of all rolled up into one. One of your equations is f of x equal 4. The other one's f of x equal 4 minus x squared, and then the last equation in your piecewise is f of x equal 2x minus 6. The first part of your piecewise are the equations that it consists of. The second part of your piecewise tells you where you can graph your function or the numbers that you're going to be allowed to plug in. It's the domain. Okay, so the domain of f of x equal 4 is any x value that's less than or equal to -1. So if I were plugging in numbers into this equation, I could plug in -1, -2, -3, -4, -1,000,000, anything less than or equal to -1. But as far as graphing goes, we're going to go ahead to where -1 is on the x-axis, and I'm going to section off that piece of the graph paper. So if I'm making my ordered pairs, I could only use numbers that are less than -1 or equal to -1, which means that when I graph it, it's only ever going to fall over on this portion of the graph paper right here. These are the ordered pairs that actually use those x coordinates. So as I generate an ordered pair list, my graph would only show up over here. You would never draw it to the right of -1. And then my second graph is going to be using x values for its domain that are in between -1 and 2 and also including the 2. So when I go ahead and graph this guy, his ordered pairs are going to fall in between -1 and 2. So I'm going to split my graph paper up right here. And then finally my last function, f of x equal 2x minus 6. He will be graphed for x values that are greater than 2, which is over here on the right side of the graph paper. So any x value of 2 on can be plugged in that equation, and all of his ordered pairs are going to fall over here to the right. And then you can graph these like a bunch of different ways. I know that the first equation is a horizontal line. I know the second equation is an upside down parabola, and I know the third equation is a line that has a positive slope going uphill because I have a lot of experience in graphing lines. But if you don't have a lot of experience in graphing, I shouldn't just say lines, but equations like parabolas and lines with slopes and horizontal lines, if you don't have a lot of experience, you can just go ahead and do an XY table, which is what I'm going to do for the example, because that'll take care of everybody in one shot. So for the first equation here, I am going to pick a couple ordered pairs that are to the left of -1. So let's go ahead and do -1, -2, -3. Now this is the kind of strange equation that when you try to plug in one of your x values, there's nowhere to put the x in. So you get what you get. I don't have a spot to plug the -1 in, so my y value is going to be what was already there, which is 4. There's really nothing to calculate because you don't have anywhere to put the x in. And then f of -2 is going to be -4 because I can't plug the -2 anywhere, and f of -3 is also going to be 4. So everybody turns out to be 4. And then you can see when you're graphing this, if we are back 1 and we are up 1, 2, 3, 4, back 2 up 4, back 3 up 4, that creates a horizontal line. Now if you know that already and you know that that's going to be a horizontal line, then you can just go ahead and go up 4 and draw your horizontal line in. You don't have to find a bunch of ordered pairs. And then the symbol here says for x values that are less than or equal to -4. which means, I'm sorry, less than or equal to -1, which means we're using the -1 as one of our ordered pairs, so that's going to be a closed circle, and I'm just going to emphasize that right here, and then draw my horizontal. Okay, so that's that guy. Now we have f of x equal 4 minus x squared, and I'm allowed to use ordered pairs in between -1 and 2. I already know that that's going to be a parabola because of the x squared, so I'm going to pick lots of ordered pairs. I'm going to use everything in between -1 and 2. So we have -1, 0, 1, and 2. Now technically it would be illegal for me to use the -1 because I'm supposed to be using x values that are greater than but not including -1, but I'm going to still use it anyway for my ordered pair list. I'm just going to make sure that as I'm drawing that endpoint that I put an open circle there. And then on the other side, because I'm including the 2, it's going to be closed. Okay, so f of -1 is equal to 4 minus -1 squared, and that is going to be 4 minus 1, which is 3. And then f of 0 is equal to 4 minus 0 squared, which is going to be 4 minus 0, which is 4. And then f of 1, 4 minus 1 squared, which will be 4 minus 1, back to 3. And then finally f of 2 is 4 minus 2 squared, which is going to be 4 minus 4, and that's 0. And then my points are going to be -1, 3, 0, 4, 1, 3, and then 2, 0. And so here's my parabola. Now I just have to make sure that I put the correct endpoints on. This guy needs to be an open circle. Let's see if I can get rid of that little dot in the middle. And then this guy over here should be a closed circle, so I'm going to emphasize that. And then he's done. And then lastly, I have f of x equal 2x minus 6. And I'm going to use numbers that are 2 and on. Technically, I'm not supposed to use the 2, or it's values that are greater than 2, but I'm going to use it anyway and just make sure I have my open circle there to show that it doesn't really count. So I'm going to use 2, 3, and maybe 4. And I know it's a stick straight line, so I really only need 2 points, but I'll just do a third one anyway. If they don't come out straight, then I know I did something wrong. So we have f of 2 equals 2 times 2 minus 6, which is 4 minus 6, which is -2. And then we have f of 3 is 2 times 3 minus 6, which is 6 minus 6, and that's 0. And then f of 4, last one, 2 times 4 minus 6, which is 8 minus 6, which is 2. So that last guy is 2. And then we are over 2, down 2. I don't really feel like erasing, so I'm going to make sure I just put my open circle there. And then over 3, up 0, over 4, up 2, and it looks like a nice straight line. And that's it. Now I know how to graph a line using slope-intercept, so if I wanted to, I could have just used an illegal part of my graph paper and gone down 6, and then used my slope up 2, over 1, up 2, over 1, up 2, over 1, and continued onward. And then once I drew my line into place very, very lightly, I would erase this part of the line that would be to the left of 2 here. But if you don't know how to quickly graph a line, then you can use an XY table and putting in ordered pairs that are in that domain of that piece of the function.